All right, so 15 here. So researchers are looking at the effect of pH level on the breeding habits of this kind of jellyfish. They're going to randomly assign one of 3 treatments to the water in the tanks that hold the jellyfish, which the following is the best reason for randomly assigning. So just this is in general. I mean, they give you this specific scenario, but the reason you are randomly assigning in general is exactly this answer. Although, like, forget the water temperature, but what we're trying to do with randomization is minimize the effects of uncontrolled variables or confounding variables. You'll hear people call them lurking variables, so that they're not mixed up with the treatment effects. So there's other things that would affect the breeding habits besides just the pH level of the water. And what we're hoping is that by randomly assigning them to 2 groups, all of those other things that matter get evenly split up into the 2 groups. And then we know that the 2 groups are kind of randomly as similar as possible, so anything that, any result we get from that is attributed to the pH level. Randomization will not make up for a poor experimental design. That doesn't work. Randomization makes analysis easier because the data can be entered in any order. That doesn't, like, even if data's in, you can sort it. That doesn't make a difference. A statistical consultant will take your money no matter what. So that's no good. And then randomization wouldn't need to be replicated. So those are all reasons for bad answers. I'm not going to talk through all the bad answers all the time because otherwise the video gets too long, but I thought that was a worthy one. All right, if I go to 16. Okay, new type of desk chair, 30 volunteers, new desk for 2 weeks, and the current desk for 2 weeks. So which chair do we use first? The coin is flipped. Okay, so that's important because the order might matter. So it could be that if you use like the old desk for 2 weeks and then the new one, just the fact that it changed, there's a change there. If everyone did the old one first and the new one second, there could be something about a new desk that, oh, it's new, I like it better. But if you mix up the order, you're kind of taking that out of the equation. At the end of the 2-week period, they were asked to rate their satisfaction. So what do we got here? So it's not well designed because they were allowed to volunteer. Well, some things you can't control who volunteers for the experiment. What you do is randomly put them into groups. You're not necessarily going to get like a random selection of all the people in the world. And then you can't try to generalize beyond where we were, but we don't need to randomly select patients. We just randomly select them, put them into groups. Only 1 new chair was used. At least 2 new treatments must be used. No, we got 1 new treatment, which is the new chair, and 1 old treatment. I'm talking through the wrong answers again. This is going to get too long. I'm sorry. It's well designed because there is random assignment. We said who goes where. There's replication because we did it with multiple people. And comparison of at least 2 treatment groups. So yes, we did the chair, or no, we didn't. Or the new chair or the old chair. Sorry. So that one is E. 17. 20 pepper plants randomly assigned to 2 groups. So we got 10 over here, 10 pepper plants, 10 over here. These are going to get A. These are going to get B. Everything else is going to be the same. What's the experimental unit? So I'm thinking it's going to be some like conceptual question. But the experimental unit is just what you're doing the experiment on. And that's the 20 plants in the 2 groups. Yeah, that's it. So that's semi-straightforward. Do you know what the experimental unit is supposed to do? And that's just what you're doing the experiment on. 18. 27 stores with shoppers of similar characteristics. So they're kind of saying we put them, that's like their attempt at randomly doing it. Yeah, so you got 9 combinations of 3 price levels and 3 packaging types. So you got like cheap, medium, expensive, and then 3 packaging types. So I don't know what those would be, but that gives you like 9 total combinations. And then they're saying which of the following best describes the design. So You are randomly putting things into one of those 9 things that we talked about. You are not splitting into subgroups. So if you're splitting into subgroups, that's a black design, but we're not splitting this into subgroups. We're randomly putting them into one of the combinations. And what we're doing is, yeah, so that's it. 19. Dog food company, we got a new high protein formula to see if it helps gain weight faster. Puppies will begin being weighed at weaning and will be weighed at 1 month intervals for the year. In this experiment, the investors wish to reduce the variability due to natural differences in puppy growth rates. Which of the following is most appropriate? So yeah, different kinds of puppies are going to grow at different rates, right? So we want to split them into subgroups. So first of all, block versus stratify. They're the same concept, but stratify is for choosing the people for your sample, and block is doing an actual experiment on them. So these are all the same concept, but don't choose C, D, or E, because if you're doing an experiment, that's block. So A and B is what you get down here. And what are you going to block on? So what are you going to make your subgroups based on is what that's asking. So your choice is, do I think that dog breed has an impact on puppy growth? Or do I think more so that geographic location has an impact on puppy growth? And I think it's definitely dog breed. Certain types of dogs are going to grow faster. I don't think you're going to necessarily grow faster if you're in like a sunny part of the country or by the ocean or something. So 19 is that. Number 20. All right. 60 babies, a puppet show. The red puppet's trying to open a heavy box. Second puppet helper would try to help the red puppet. The third puppet called the hinderer would try to slam the red box down. Dang, that's mean. After watching the show, each baby was presented with a tray containing the helper puppet and the hinderer puppet and record which one they reach for. So they want to see if they're going to reach for the helper puppet more than the jerk puppet. As part of the show, a green puppet and a yellow puppet served as the helper and the hinderer. For each baby, a coin was tossed to see which was which, so they randomly are choosing. So the reason for that is it could be true that babies just naturally prefer green or naturally prefer yellow. So to make sure that that is not causing anything to be mixed up with the experiment, we want to randomize that, and that's to make sure that color is not having any kind of impact. So that is C. 21. 18 individuals who use a particular form of social media or assigned a new user interface. After using the new interface for a week, they were asked to rate how easy or hard it was. That is not an experiment. I guess that's what they're asking though, right? Which of the following correctly identifies, well, this is not a well-designed experiment? So the answer is E. Again, I don't want to talk through all the wrong ones because we're coming up on 10 minutes, and that's kind of my cutoff. But I'm happy to if you guys want to let me know later. If you're going to do an experiment, you got to compare it to something. So there's got to be a control group, or there's got to be like 2 groups, like this interface versus this interface. This example here really should be the new interface versus the old interface, and you compare which one you like better. This is they're just getting a number. Do you like this? Yes. Okay, well, we proved that doesn't prove anything. One more. 22. So if I remember right, this is matched pairs. Okay, sex and genetics of the lambs can affect their weight gain. 5 sets of male twin lambs and 5 sets of female twin lambs. Okay, so we think sex and genetics matter, and then they tell us conveniently we have male twins and female twins. So we're going to make 10 blocks. So what I'd want to do here, because I got twins, this is a block of group 2. This is a subgroup of group 2. So I've got like male, twin A. Why does that keep happening? Twin B. Male, twin A, twin B. And I've got 5 of those. And then I've got female, A and B, and female A and B, and I've got 5 of those. And so I have, it's like I'm making 10 experiments. 1, 2, 3, 4, 5 on the males. 1, 2, 3, 4, 5 on the females. And you're making these blocks of size 2 where within each block they're as similar as they can possibly be. So these are twins. They're male twins. They're both males. They have the same genetics. Not the same, but pretty close. So that is a matched pair design. Matched pair is when you're blocking based on size 2. That's what we have here. So that one's E.